Hey you guys, Lissandro here, and today I'm gonna do another blog. So today I wanna actually it's kind of like it's gonna be a combination of blog and uh kind of a whiteboard tutorial. But what I want to talk about is lately I ordered some speakers for my laptop because the speakers that I had were pretty much crap. They work really well for a good while. They had good quality, but the thing is that there's a lot of things fucking up on them and all. I think they were about like 10 years old or something like that, and I got tired of them. So what I did is I just pretty much threw them aside and everything, and decided to look online and. I didn't. I'm the type of person that doesn't like to spend too much money on something because let's say I do buy something high quality and pay a substantial amount of money, even if it's worth it. It's I feel bad later on based on how much money I spent on it. But anyway, I want to go ahead and bought some really cheap speakers in it. I didn't think much because it had all everything, the power button, volume control, and best of all, it was USB and audio jack connections and all. So hey, what's the difference and everything? And I put it in there, and it was pretty much crap because when you when you hear the audio, you there's a difference between just hearing what you're hearing and the difference in not only hearing but actually hearing the actual quality of it, and as well as literally feeling the audio. And what I mean by feeling the audio, I don't know if y'all heard of they call 3D sound, and it was around back a couple of years. I don't know if it's still around or not, but 3D audio is literally that type of audio in which you can literally hear it like if it was in present time. So if you're playing the audio of somebody breaking glass or hitting a pan or hitting something, you can literally hear it in the background. It's that type of audio that if you hear something like, let's say something break, you won't hear it in the speaker. You'll turn around and look because you think you heard it. That's the type of audio. That's the high end quality audio that I'm talking about. So the thing is, why how much you pay, does it matter or not? Yes, a lot of the time it does, because the thing is that a lot of the times you're buying like, I don't want to say this, but it's kind of cheap Chinese quality, and the reason why I mention Chinese or Taiwan in some cases is that there's a lot of products. Not everything's crap that you order from China. There's some really good quality stuff. But the thing is, a lot of it, there's a lot of electronic stuff that is satisfactory. It's not high end quality. And the thing is that that's all due to the poor engineering and some of the products. And let me show you what I'm talking about. Okay, so what I'm talking about is this. Let me show you. A lot a lot of y'all may not know, but there's electrical current. Usually they talk about DC and AC. Okay, now what you get in speakers, audio, whenever you deal with audio, you're always gonna deal with AC, okay? And the deal is this: you for the basis and pretty much in amplifier design is that you always deal with frequency. You always deal with frequency like your sine wave. This is your hold on. Let me draw it right. Okay, so this is your time frame, and this is your sine wave. Okay, depending on the frequency you get from the audio. That's what you're gonna get. Okay, but the one of the problems that you run into whenever you're dealing with audio, whether you're dealing with that clean quality audio, is that there is always distortion. There's always distortion, and there's always a problem in audio acoustic engineering. Is that there is always some grade of distortion that you pretty much end up dealing with, and because of that, you always deal with something. For example, if you're talking on a speaker, you always deal with like distortion from the air that's coming out of your mouth. And that's if you have a microphone in or you're getting any sort of background sound, or in like earbuds, headphones, you're always dealing with some sort of audio issue, magnetic resonance, all sorts of different distortions affect the audio. But a lot of the time, it's thermal noise. And what I mean by thermal noise is that it's noise that you can't get rid of because it's the resonance in your circuits. Sometimes be averted. That can be averted depending on the type of engineering you have. Sometimes because of poor engineering, you have a really bad audio, bad amplifier design. When you're getting into amplifier design, everything is very meticulous because you're always gonna deal with some. Um, Let me see if I remember. I think it's like this on the. Yeah. Okay. So you're dealing with transistors, and there's all types of transistors. There's MOSFET, all field a type of field effect transistors. There's also junction transistors. There's your PNP, your NPN, and what I mean by this is that if y'all know diodes, diodes are like have like two junctions. There's a positive and a negative. Well, and transistors can be positive, negative, positive, negative, positive, negative, or vice versa. And you have all these. So for example purposes, I'm gonna explain with this. So one of the common problems, and this is in microphones and speakers, wherever you apply any form of amplification, and this also applies in telecommunication. You always deal with um, some sort of problem with muffling. And what muffling is that it's some sort of noise like you. Let me see if I can do it. The hello, like for example, if I'm talking loudly or something like that, and um, you hear some sort of some sort of distortion, but like for example, if somebody's yelling on the microphone or something like that, you always hear like muffling. I don't know if I did it right, if it actually caused that distortion effect I was trying to simulate and all. But anyway, um, so these are your resistors. Okay, I know they're kind of crappy looking and all, and remember this is because of this stupid tablet that isn't is not doing it. Is not doing its job and everything. Okay, and you have electrolytic capacitors, and okay, and the thing is that let me go ahead and explain a little bit. Okay, this is your DC power source and ground. Okay, okay. Let's say this is like 12 B DC. Okay, let's say this is 12 volts DC. All right. The thing about this is that um, in order for you to get a signal, whether it's in telecommunication, audio, or whatever, in order for get you to get a frequency like get jump this, which is really low based on your volumes, which is your dB, your decibel. Hold on. Okay, which is your decibels, your dB. Okay, in order for jump this to something higher, something like this, you need an amplifier. You always need some sort of amplifier to boost up the signal. And this is especially in telecommunication because in telecommunication, especially those large satellites, you don't deal with millivolts. You deal with microvolts. You deal with microvolts. That's how extensive, meticulous that thing is. You use a lot of amplification just to boost up a really minute signal. That's how advanced telecommunication has gone, and they use a lot of stuff like superconductors and all. But I'll get into that some other time. So basically, what happens is you you deal with a very minute signal, very faint signal. Okay, let's say this is your voice. Let's say this is you right here, like yelling, yelling as loud as you can. And yes, this looks like a duck and all, but that doesn't matter or anything. And the thing is that you get this signal and all. Okay, and you need this to keep like any DC signal from coming through here. Uh, since a lot of the times you deal with multiple stage transformers, there's like two stage, three stage, and so on, and it gets more complicated. Uh, okay, so this signal goes through here, and if y'all know transistors, these are like gates. These only, depending on which ones you have, this is a PNP. These ones only close when there's signal going through. So if you remember um, beta DC times your IB, which is your current from here, it equals to IC, which is your current here. So to get to the point, a lot of the times when you have like let's say like a overly large signal here, let's say it's not this, let's say it's this. A lot of the times, the power supply isn't strong enough to supply the amplifier with enough power to amplify this. So your end result, when you hear all that muffling, uh, what actually is happening is that the ends and tips of your frequency waves are being truncated. They're being like rectified. So let me go. Or I think I explained it here. Instead of getting a nice clean sine wave like you're supposed to get, what you're getting instead is you get. Or let me go ahead and erase this. It's annoying. I really hate drawing on like really limited space. Okay, so instead of, like I said, instead of getting a nice clean wave, instead um, you're getting something like this, and it's all truncated. You're getting more like a truncated wave. Everything in between is fine, but beyond that, it muffles and everything. That's why the muffling goes away whenever you lower the volume. When you try to increase the volume to a certain extent, it starts to muffle, and sometimes the speakers start to vibrate or something like that. And that's usually what happens. So anyway, um, that's one of the examples. Another other examples could include like port sign and everything. Like for example, like really weak designs. Let's say if you had like you required a three-stage amplifier. You only use a simple amplification process, and you have to keep in mind that thermal noise gets in the way and everything. So as you can see there, this I gave you an example. Some of the one of the issues that goes on with these speakers, these it's not only speakers, it's also microphones like the one I'm talking in and on. That it always because of poor design, it also you always sacrifice quality. Now, if you're gonna buy speakers or microphones in which pretty much you don't give a shit about the quality. You just want to hear something uh, and all without regard or anything. Like for example, a lecture where you're trying to hear a lecture, and everything you can hear it clearly and everything, but you really don't care about the audio. Then a really cheap pair of speakers, that's fine. But if you want like you're hearing music, you're hearing anything of the sort like that, then one of the things I would recommend is go ahead and pretty much go ahead and get speakers that are really high quality and all. But keep in mind, based on what you pay, a lot of the time is what you get in quality. If you want to buy something dirt cheap, that's the type of quality you're gonna get. Now, this isn't across the board, of course. Sometimes you're fortunate to get really high quality stuff at really cheap price. But remember, if you uh, if you want really high quality, actually invest in getting something like that. Invest in getting something high end. But anyway, I guess this will be all for now and everything. Thank you for watching. Please like and subscribe, and I'll catch you guys next time.